I'll zoom is that. No, again. It's just zoom on. Something wrong with zoom. It's a little glitch in the matrix there. All right, nice. So let's take a look at a plane, right? So let's say a plane, as I said, a plane is a sheet of paper, right? What do we need to get the equation of that plane, right? So we're trying to get the vector equation. Trying to get the vector equation of a plane. Right? So as I said in 3-dimension, right? A plane is just a piece of paper, right? Like a one sheet of paper. We're trying to find the equation of this plane. Right? How do we get the equation of that plane? We need two things. We need something to give us direction. So what we use is a vector perpendicular to the plane. Let's call it N. It is perpendicular to the plane. Right? Then we do the same thing again. Just as before. We get a point on the plane. Right? Let's call that point A. Right? And we know that point, and then we have some random point R. Right? Let's draw them. Right? Let's draw them relative to the origin. Right? The vector AO, right? The position vector AO, let's call him small a. And the vector position vector ROR, let's call it small r. Right? So can we find AR? The reason I want to find AR is that remember we know this relationship. If two vectors are perpendicular, what we know? If two vectors are perpendicular, what we know? We know that the dot product is 0. So it means that if I know AR and I know this vector, when I multiply them, I'm supposed to get what? Right? So we know that E dot B is equal to 0 if perpendicular. So that's the reason why we're going after AR. Right? So AR is what? AR is vector AR is A to O, O to R. So it's A to O plus O to R. A to O is minus A, and O to R is R. So we can say that AR is equal to R minus A. Are you okay with that? Yeah, that's a rule. That's a rule for two things perpendicular. Yeah, that's a general thing. Yeah, that's general. So, right. So since AR is perpendicular to N, then we can say that AR multiplied by N should be 0. Are you okay with that? So AR is this. Right? And well, N is that. When you multiply it out, what you'll get? You'll get R by N minus A by N is 0. Right? Or more formally, R by N is equal to A by N. That is your vector equation of the plane. Right? Of course, we'll know N, we'll know A, and R is any random point. So this can be written like this. Remember, R is any random point, right? R is any random point, so that'll be X, Y, Z. N is the perpendicular vector. Let's call it alpha, beta, gamma. And when you multiply E by N, right? When you multiply E by N, you will get some value. That's not I'm adding these two people. Yeah. Right? When you multiply this out, you'll get some value. Let's call it T. So alpha x plus beta y plus alpha x, beta y plus gamma z is equal to d. Right? This is the Cartesian form. Right? This is the vector form. Right? And I'm going to show you how to do it now. Right? Copy it up. And just a little idea where it came from. Right? So you'll know what you're using now. Right? So this is the vector form and this is Cartesian. If I was A is the point on the plane, and the point on the plane, you can write it like this. Right? 5, 1, 2. And they give you the perpendicular vector, so you know what n is. N is 3 minus 2, 1. Right? So to get the vector equation on the plane, right, let's start with the vector. To get the vector equation of the plane, all we have to do is use a little formula there, r, right, by n is equal to e by n. As I said, r is any vector, right? So it's r by n is 3 minus 2, 1 is 5, 1, 2, n is 3 minus 2, 1. Right? Okay with that? So you just plug it into this formula, right? So it will be the vector form will stay like this, r by 3 minus 2, 1. Actually, write it like this, 3i minus 2j plus k. Then you work this out. Then we work out this product, right? 5 by 3, 15. 1 by minus 2, 2 by 1. So you will get 50. That is your vector form. So this here is your vector form. Then you want to get a Cartesian. To get a Cartesian, you come back right here. You come back right here and you write x, y, z by 3 minus 2, 1 is equal to 50. So you multiply this out, you will get 3x minus 2y plus c is 50. This here is your Cartesian.